Hi guys, sorry we ran out of time on the last video and I only got done with 2 stations. So starting with station 7 on this video, this is the standard investigate and apply how the cycling of water between the atmosphere and hydrosphere has an effect on weather patterns and climate. So again, I'm not going to do the probe with you so that we can get everything done. This is a picture of the water cycle. You were to use these terms to fill out the picture on the front. All right, so in number 1, you have water that is being heated by the sun, rising up into the air. This is called condensation. As the water vapor rises into the air, it starts to cool and it forms clouds. When those clouds get saturated enough, you will have precipitation. All right. On the other side here, you have a large body of water. Okay. You have evaporation coming off of that body of water due to heat. That also will lead to condensation. So at number 1 and number 3, you're going to have condensation, which leads to precipitation. Number 4, you have transpiration, which is from water evaporating from plant leaves, okay, which goes into the atmosphere, condenses, and then comes down as precipitation. You have surface runoff, subsurface runoff, and then large bodies of water would be called accumulation. Okay, the rain shadow effect we went over in class. The definition, I don't think I gave it to you, but here it is right here. It's an area having relatively little precipitation due to the effect of a topographic barrier. The example that we definitely gave was the mountain range, the Sierra Nevada, that's in Southern California, that causes prevailing winds to lose their moisture on the windward side, causing the leeward side to be dry. So in this case, this would be your windward side, this would be your leeward side. And we went over the summary in class together. All right, station 8. So describe how global patterns such as the jet stream and ocean currents influence local weather in measurable terms. Going to the Edpuzzle video questions. Number 1, temperature changes the air pressure. So as you have the sun heating up water, land, air, whatever. See if I can get this to focus. Hold on. It's going to cause changes in air pressure. When we're talking about air pressure, we're talking about how much, like if this is the land, okay, air pressure is the amount of force the air has pushing down onto the land. So this would be air pressure, okay? And when you have cold air is dense air, means it's heavy, okay? It's going to push down on the land a lot more than hot air, okay? So cold air is going to push down and give you a higher air pressure than warm air. Warm air is going to give you lower air pressure because you have it evaporating off of the surface of the earth, which is going to cause less pressure. So I'll put over here just for hot air. Number 2, warm air weighs less than cool air and creates a low pressure area. This is because it is less dense and rises off of Earth's surface. Number 3, cool air is heavier and creates an area of high pressure. Number 4, wind moves from areas of high pressure to low pressure. So if you have an area, like here, where you've got cold air sinking and giving you high air pressure, okay, and then you have a spot that's right over here where you have hot air rising, this is going to give you low pressure, okay. As if this hot air is rising off of Earth's surface, it creates a void down here, and this will cause the high pressure air to move from one place to another to relieve the pressure. So this is what we would call wind. As it moves from an area of high pressure to low pressure, that is called wind. That is what you feel. Number 5, a jet stream is a narrow band of fast-moving air that's about 8 miles above the Earth. Airplanes use it to move faster, and we definitely have changes in weather due to this jet stream. Number 6, the curving of air above Earth's surface is due to the Coriolis effect and is a result of the rotation of the Earth. So this comes into play when you're talking about global winds, because you have large areas of wind on the Earth that move in certain directions. Like, for example, you have the polar easterlies that move in a specific direction because the way the Earth is rotating. Okay, so the Earth is rotating and it's causing the air on the surface to also curve. That is called the Coriolis effect. Number 7, Hadley cells are masses of air that move in circular motions. These are also called pressure belts. Now, back in 6th grade, we talked about this. This is the equator. Okay, these Hadley cells or pressure belts are areas that happen at every 30-degree latitude line. So you've got 0 degrees here, we've got 30 degrees, 60 degrees, and then 90 degrees up here at the top, where the North Pole is. So the same thing happens down here, where we have 30 degrees, 60 degrees, 90 degrees. At particular areas, you've got differences in air pressure on a global scale. For example, at the equator, you've got super hot air because we're at the equator. Temperatures are hot at the equator. So we have air that's less dense and rising off of the surface. As it gets away from the surface, it cools, starts to condense, and then it goes back down towards the surface, and it kind of circulates in these little convection cells. That's what these Hadley cells are. So at every 30-degree latitude lines, things, or the pressure belts, kind of change a little bit. Number 8, fronts are boundaries between two air masses that are colliding. Okay, to the next Ed Puzzle video, how do oceans affect our weather and climate? The two basic types of winds are global and local winds. Convection is where heat moves through the atmosphere and causes local winds and breezes. Number 3, different materials like land and water soak up the sun's light energy in different amounts. During the day, the air over the land heats up faster than the air over the water. This difference in air pressure causes wind to move from the sea to the land in a breeze called a sea breeze. It's called this because wind is named by where it comes from. Okay, so let me get a piece of paper here. When we're talking about local winds, you've got the sun, okay, you've got water, and you've got land. All right, now as the sun starts to heat things up, it is going to heat up the water a lot slower than it heats up the land. That is just characteristics of certain materials. Water takes a lot longer to heat up than solid land. So as this happens, you've got hot air over the land because the land heats up faster, rising, okay, causing an area of low pressure, okay. Over the water, you've got cooler air because it takes a long time for the water to heat up. So you've got that air sinking, causing high pressure, okay? And we know that wind moves from areas of high pressure to low pressure. So during the day, you're going to have this movement of air as wind from high pressure to low pressure. This is called a sea breeze because wind is named after where the wind originates from. So it's coming from the sea going towards the land, hence it's called a sea breeze. Now at night, okay, the opposite thing kind of happens. So if you have a moon, don't make fun of my moon, and you've got the same water and then land, okay, the land now is, the water now is super hot. Not super hot, but it's hot. It's hotter than the land. Because due to the nature of the material, once that water holds that heat, it takes a long time for the heat to go away. So now you have the water being warmer than the land. So you've got air rising over the water, causing a low pressure area. And then you've got air over the land that's much colder because the land cools down a lot faster. You've got the air sinking, causing an area of high pressure. Okay? Then you've got the wind is going to move from areas of high pressure to low pressure. Okay, and this is called a land breeze because it's coming from the land going towards the ocean. Okay, so these are two examples of local winds. We've got sea breeze and land breeze. Then, I think we're on number 5, global winds are caused by air cycles or Hadley cells. Number 6, if the ocean water is cold, it will make the air cold above it. If the ocean is hot, it will make the air above it hot. This affects weather patterns. Local atmospheric conditions include temperature, air pressure, wind, and moisture, like humidity, and these make up the elements of weather. Number 8, if one particular weather pattern is common to an area, we call it climate. Okay? And then the summary is, which elements of weather are influenced by global patterns? When we talk about elements of weather, we're talking about the specific things that make up different types of weather, like temperature, precipitation, wind, humidity, visibility, and air pressure. Visibility is going to be how far you can see, like on a foggy day, which we are accustomed to around here. Visibility might be low if it's super foggy. Okay, humidity is something that we totally know a lot about. It's the amount of water vapor that is in the air. Wind, precipitation, temperature, and air pressure. Okay, that is station 8. Alright, station 9 is really the review of all of the stuff that we've done from stations 1 to 8. So, the review question is, what are the internal and external sources of energy that have continuously altered the Earth's features? Alright, so we know that the surface of the Earth changes all the time. Okay, and there are external things and there are internal things that help make that change happen. So when we talk about internal sources of energy that help change the Earth's surface, we're talking about convection in the asthenosphere. Okay, so inside the Earth you have these dynamic things that are happening that cause these changes on the surface of the Earth, and that is particularly happening with convection in the asthenosphere. Convection is going to cause earthquakes, volcanoes, the movement of the tectonic plates, which cause mountains, rift valleys. Those also cause earthquakes and volcanoes. So all of this stuff is connected. Okay, this is what happens on the outside, but this is what's happening on the inside to make this stuff happen on the outside. The external forces are going to be weathering, erosion, deposition. Okay, so those things are going to also change Earth's surface, but those are caused by external things like weather and wind, water, gravity, those types of things. How can the flow of energy and the cycle of matter contribute to global patterns? Heat from the sun and heat from inside the Earth are constantly moving matter. An example of matter that I gave you is lava, and energy in the form of heat around Earth. This causes us to have global winds, weather, climate, ocean currents, pressure belts, earthquakes, volcanoes, mountains, valleys, blah, 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 blah. All of the stuff that we've been talking about in stations 1 through 8. Okay?